Hey guys, welcome back. Today in this continued series of pipe design, Casey's going to walk us through an alternative method for calculating hydraulic grade lines, and he's going to do this directly through Civil 3D. So let's watch and have Casey show us how to do these hydraulic grade lines. Let's learn.
Welcome back, guys. This is Casey. Today we're going to be continuing our Civil 3D pipe series, and we're going to be going over how you can use Civil 3D to do your HGLs. So the first step that you're going to want to do is you're going to want to create your catchment areas. So catchment areas is an entity in Civil 3D. If I pull over my tool space here, you can see that we have catchments here. So if I navigate to the Home tab, we're going to want to look for our catchments, which I don't think is actually in the Home tab, so I'm just going to go ahead and type this in just so I can find it a little bit quicker. Should be catchments, but we can right click, create catchment group. Cool. Okay, so you can create a catchment group for basically all of your different separate pipe networks. If you remember working in this project here, we've got this northern pipe network, which we've set up for all of our videos and demonstrations here. We also have this network down here to the south, which we haven't set up in our demonstrations just for the purpose of not being redundant. But you can go ahead and create a catchment group for each one of these. So this catchment group is just going to be the Storm A catchment group. Just go ahead and hit apply. Okay, cool. Now we have catchments, and then we can go ahead and we can create catchments from object, right? So we actually already have, I'm going to go ahead and drag the tool space over here to my other monitor. So we already have these drainage basins delineated for each one of these separate inlets. So we can go ahead and use these polylines that we've created, and we can just grab them, and you want to make sure that they're closed polylines and that they're including or closed in on the area that you intend for them to be closed in on, right? So I'm going to do the same thing. I'm going to right click, I'll drag this over again just so we can see. I'm going to right click on our catchment group, and then I'm going to select create catchment from object. And then I'm just going to go ahead and grab one of these polylines. Cool. And then it's going to give you this option, select a polyline on the uphill end to use as a flow path. This is if you want Civil 3D to calculate your time of concentration for you. So in some cases this may be useful, but we're going to go over that another time. So we're just going to go ahead and hit escape to skip. Okay, and now this is going to open up this little creation tools menu for us. And the first thing you're going to do is you're going to want to select your reference pipe network structure. So this drainage area that I just selected drains to this structure A7. So I'm going to go ahead and click this little button right here, which is going to allow me to select the reference structure in plan view. So I'm going to go ahead and grab this guy here. Okay, and this structure is named A7, so I'm just going to name the catchment area name A7 as well, because it's the area draining to inlet A7. And then the catchment style, we don't have any personal styles for these, so these are just all going to stay as standard. And then the runoff coefficient, we have this 0.50 runoff coefficient already defined, and that's what's here in this box by default, so we're just going to leave that alone. And then if you click this little tab here, flow path, if you want your catchment area to define the time of concentration, and you did do that little flow path selection option that we just talked about, you can come in here and select your calculation method, and then you can select the object in which it's going to calculate that from, but we're not going to do that right now. Go ahead and click OK. All right. And then that's just going to go ahead and it's going to use up the polyline that we just created, right? And it's going to create this catchment area. So if I grab this guy, let me move my tool space out of the way. I'm going to drag my properties pane over here. If I grab this guy, which we just created, as you can see, that's the label there. So it says AECC, which is a Civil 3D entity catchment area label. And then when I grab this outer boundary here, it's my catchment area. So you can go ahead and you can repeat that process for each one of these. So that's what we're going to do really quick. So we're going to do Storm A, create catchment from object, grab the polyline, hit enter. Okay, this guy is going to go to a 4.1, so it'll be named a 4.1. Okay, we'll select the reference pipe network structure, which is going to be this guy. Layer is going to be 0 for now, not doing the flow path. It has a runoff coefficient of 0.5, so all of that looks fine to me. Go ahead and press OK. Cool. We'll do the same for this guy. We'll go ahead and create a catchment from object, select, hit escape to skip, and then this is A6. We'll go ahead and select our structure A6. Styles all standard, catchment layer 0. All right, and then if you have this box checked here, this erase existing entities, that's what's going to go ahead and get rid of the polyline that we use. So we've had that checked for the last two, which is why this polylines disappear. If I don't check that box and hit OK just to show you guys what happens, it'll create my catchment area here, but it actually left the parent polyline that we used to create it, which we don't really need anymore, so we can go ahead and get rid of that. We're just going to continue along with this process. Create catchment from object. Grab this guy. Leave that checked. This one's going to be going into what looks like A5. We'll go ahead and select the structure. A5. Standard, layer 0, standard, okay. All right, we'll go ahead and just do our A4 now, which is this guy. A4, select the structure A4, right? And then all of these catchment areas are eventually going to be put on our CZ Hydro Storm layer, which is the layer that we use for our drainage area. So you can go ahead and under this catchment layer area, click this little button here, then this little button right here, and then select that layer, press OK, and then standard, runoff coefficient 0.5, press OK. All right, cool. And then it's just going to go ahead and it's going to put it on that layer. I feel like it's a little bit tedious. It's a lot of buttons to click every single individual time that you do it. It's much quicker to just do all of them on the 0 layer, select them all, and then put them on the layer after the fact. So we're going to continue doing it like that. But if you want, you're only doing one catchment area or something like that, might be quicker for you to do it that way. So we'll just go ahead and continue, create catchment from object. Right, this guy is going to be going to structure A3.1, so we'll name it A3.1. Okay, standard, coefficient of 0.50, looks good to me. Go ahead and press OK. Go ahead and do this guy, which is draining to A3. Standard, 0, standard, 0.5, cool, looks good to me. All right, and then this guy needs to be broken in half because this guy is being split just about evenly between these two structures, so this one hasn't been broken in half yet. So if I were to create a catchment area for this one, it would only be able to reference one of these structures and not the other one. So I'm just going to go ahead and I'm going to break this guy in half here. Run the command BO just so I can kind of split it. Cool. Okay, so now I'm going to use this area for this inlet down here. And then the other inlet, I'll just go ahead and turn on these areas again. Okay. I'm going to adjust these two guys to be a little bit more accurate. So this guy here is probably going to be more like this. Cool. We're going to go ahead and repeat the same process again. Create catchment from object. Select our polyline. Cool. That's going to be draining into this guy here. Runoff coefficient of 0.5. Okay, and then this is draining into inlet A1. Go ahead and hit OK. And then one more, which is this guy, which is going to be draining into A2. Go ahead and grab A2. Just like that. Cool. Right, and then now we're just going to grab all these guys. We're going to run select similar so that we can grab them all and put them on the layer that we want them on. Like this, and these all belong on the CZ Hydro Storm layer right there. And I'm going to go ahead and I'm going to make them that bright pink color. Again, prefer that color. Cool. So now we have all these catchment areas defined and they all have their own little labels, which are all going to go on this layer as well. Cool. All right, so now that we have all our little catchment areas defined, we're going to be able to use our catchment areas to analyze our storm sewer network to output our HGLs all within Civil 3D. In order to analyze our pipe network in Civil 3D using the catchment areas that we've just created, we're going to have to click on one of our structures or pipes or navigate to the Analyze tab and select Analyze Gravity Network. So once you select this button, you can either A, pick one of your structures or pipes, or you can hit the Enter key to select from a list, and it'll prompt you to select which pipe network you want to analyze. So in this case, we're going to be analyzing Storm A, so we're going to go ahead and click OK. Okay, this is going to open up this new window here for us to analyze our gravity network. We can do a variety of different things. It'll resize pipes and change inverts to help accommodate the flow running through the pipes, and it'll do this automatically for you if needed. It'll simply compute the EGL and HGL for you if that's all you want, and that's what we're going to be showing how to do right now. And it'll also do an analysis of each one of your inlets. So the first thing you're going to do is you're going to want to set your tailwater condition to crown. Make sure your outfall is the correct outfall inlet. So ours is A0 here. You can click this little button to select what structure you want as your outfall. So this is structure A0. So if we click this guy, it'll go ahead and select A0 for us. Okay, and then we're going to want to select the correct rainfall file. So if you haven't imported your rainfall file from NOAA Atlas 14 and kind of converted that into an IDF file, then you can hit this intensity table thing here, and then you can punch in whatever inches per hour values you need for the 5-minute, 15, 30-minute, and 60-minute storms that you get from NOAA. You can hit save and return, or you can select one of the IDF files that we already have in here. So this file is going to use the Lafayette IDF, so I'm going to select this guy, hit open. Okay, and now we have our rainfall data imported. And then we can go ahead and we can select network details to go ahead and review our network details. A lot of these values are going to be automatically imported from the catchment areas that we already defined, those values being the catchment, obviously. So this is the catchment that structure and pipe references, and then the areas defined by the catchment, the runoff coefficients defined by the catchment, and the time of concentration is defined by the catchment. If you need to change your time of concentration or punch it in manually because we didn't create our flow paths for each catchment, you can go to your tool space, you can scroll down in your prospector to catchments, to Storm A, and then you can select one of your catchments, hit properties, and then under catchment properties you can change your time of concentration method from the TR55 method, which is going to use that flow path that you defined, which we didn't do in the first video. You can change that to user defined, and then you can punch in manually your time of concentration. So we have 0.083 hours here for 5 minutes, and we just did that for each and every one of our catchments. So then when we go back to our Analyze Gravity Network, which I'm just going to go ahead and navigate back to that really quick, our time of concentration is 5 minutes for each and every one of our pipes and structures. Okay, all the other values, some of which you might have to change. If you change the pipe diameter or swap the parts for any of these pipes, your in value is going to reset to 0, which is going to give a non-valid error for you. So if I just go ahead and set this guy to 0 and hit enter, it's going to give me this big red circle with an X in it saying that some of the information is preventing the analysis from working. So we're just going to make sure that our in value is always punched in correctly. So for this case, it's 0.012. Okay, and then you can go ahead and hit back, and then this little caution is going to show up pretty much all the time for your time of concentration, saying that it should be reviewed because it is user defined and not defined using the TR55. That error is going to pop up pretty frequently, but that's okay. All right, and then to select your annual stormwater event, you're going to be able to hit this drop down, and you have your 2-year storm, 5-year storm, 10-year, 25, 50, and 100. So we're interested in our 25-year HGL and our 100-year HGL, so I'm just going to go ahead and select 25 here, and then hit this little Analyze button. Okay, and then it's going to give me some key information about each one of the pipes. It's going to give me the diameter, and then it's going to give me the flow and the velocity running through each pipe. Okay, and then it's also going to give me the pipe slope. The reason it's giving me these two pieces of information, diameter and slope, is because those are the first things that we're going to change to increase the amount of water that pipe can accommodate. And then for performance, it's going to tell you whether or not the pipe is performing normal, whether or not water is surcharging out of the upstream structure, or whether or not the pipe is flooding, meaning water is coming up out of the structure, not just pooling up inside the structure. So we've got some surcharging going on here. That's okay for now. We're not going to make any changes right this second, but you can change the diameter and pipe slope in plan view or on your profile, and then rerun this analysis and to get better performance if desired. We're just going to go ahead and we're going to hit apply. And then if you'd like to view the profile itself, you can go ahead and select profile here. And then it'll prompt you in your command window to select the profile view that you would like to see the performance in. So this is our profile of this run of pipe. So we're just going to go ahead and we're going to select this profile. And you can see here that the blue and pink lines are going to populate, and those are our EGL and our HGL. So I'm just going to go ahead and Control Z. So if I minimize this window here and I want to see each and every one of my pipes here, I don't know why my pipes are not showing up in the profile now. There we go. Okay, let me just go ahead and pull this window back up. I'm going to close this guy out. Once you hit apply, that's now going to show the HGL and the EGL inside of your pipe style. So the only thing you have to do to get it to populate in your profile is change and edit your pipe style such that it'll show up on your profile. So once you hit this apply button, the HGL and EGL data are going to be within the pipe itself. You just have to change some settings around to get them to show on the profile. In order to show the HGLs, you're going to want to select one of your pipes. You can go ahead and hit the pipe properties drop down so that you see edit pipe style. And you're going to go to display, and then the view direction you're going to set to profile. And at the bottom here, you'll see hydraulic grade line and energy grade line. We aren't really concerned at all with the energy grade line, so we just want to see the hydraulic grade line. So we're going to go ahead and we're going to turn this guy on or make it visible. So you want this little bulb here to be yellow instead of blue. And then we're going to change the color to whatever color we want. I like to use color 70 for my HGLs. It appears really dark, but also as a thin line. So if you have two HGLs that are right on top of each other, you can differentiate between the two, but they're not really light and really gray. So I'm going to go ahead and set that as the color. I'm going to hit apply, and then as you can see, the HGL is going to populate all throughout this pipe profile. So the key thing about doing your HGLs this way is that now that this HGL is being shown, that's going to show the HGL for the last gravity network analysis that we did. So if you rerun this looking for the 100-year storm, it's going to repopulate this HGL with the 100-year storm, and now your 25-year storm is not going to be there. So you can essentially only show one HGL at a time. If you want to show both the 100 and the 25-year at the same time, you can draw one in and then you can trace. So that's what I'm going to do right now really quick. And while I'm tracing the 25-year HGL, or after I finish tracing the 25-year HGL, we'll go and we'll draw out the 100-year HGL, and then you'll be able to see the difference. The two may be slightly different, but you will see that there is some sort of difference. So it can be a little bit frustrating to only be able to show one HGL at once, but it doesn't take but a second to trace that HGL and then go ahead and rerun your gravity network analysis, which is what I'm going to do. So I'm going to go ahead and rerun this for Storm A again. Same thing, we want the same file, so we'll just make sure that that's the same. It is the Lafayette IDF right here. And then we're going to change this to the 100-year instead of the 25. We'll go ahead and hit Analyze, and then we'll hit Apply. Okay, and once we do that, we can go back and look, and as you can see here, this green line is now separated from the white one that we just drew in to trace. So this green one now is our 100-year, and then the white one that we just drew, the white polyline that we just drew, tracing over the HGL before, is our 25-year HGL. So this is what you're going to have to do if you want to show the 25-year and the 100-year HGL on your profiles. But just one quick thing to note, if you if you do analyze gravity network, Storm A, and then you hit Analyze and you hit this profile button here and try to use this temporary view to inspect your performance results, you're going to end up getting errors with CAD and potentially CAD crashing. For whatever reason, Civil 3D doesn't seem to like doing these analysis and applying them to the profile views. So just be aware that when you hit that profile button in the top right, that is a temporary view of your HGL. And if you want it to pop up permanently or populate permanently on your profile, you'll have to select a pipe and you'll have to change the pipe style in profile view. So display profile and change this hydraulic grade line, make it visible, put it to whatever color you want, and that's how you're going to be able to get the HGL to populate. There's no way that you're going to be able to hit the profile button and then show it in the profile view and then get it to stay. If your computer doesn't crash and you hit profile, as soon as you close out your gravity network analysis box, the HGL will just disappear. So the only way you can get it to stay permanently is by changing your pipe style. So once you've done all this, you now have your HGLs shown on your profile. You can go ahead and put them on your profile sheet, and you can export and send wherever it needs to go.